Okay, this is lesson 3.2, like 3.2 for college algebra prep. We're going to start with the warm up, then we'll go through the lesson. So the first question is, how do you know if a function is quadratic? The answer is if the highest degree is 2. Degree is like power. If the highest power is 2. Next, it says draw an example of a quadratic that has two zeros. So a quadratic is a parabola, so that could be something like this. It has 1, 2 zeros. Then it says one that has 1 0. That would be like maybe this. It has 1 0. And then one that has no zeros would be like this. It doesn't cross the x-axis at all. All right, so what we're going to look at today is leading coefficient test to determine end behavior of a graph, meaning like if it goes up or down, and then find and use zeros of polynomial functions to help us graph. So first thing we want to look at is these definitions. You can read through these more carefully if you would like, but basically it says a couple of things here. It says that when n is odd, so when n is odd, that's this number, then we're going to have this sort of behavior where they go in opposite directions. So on one side it goes down, on the other it goes up, or it goes up and down. So these are opposite directions. And that's when it's odd. Odd is opposite. Maybe you remember it that way. Odd is opposite. Now, they're going to be opposite in this way, meaning it's going to start downward and then go upward if A is positive, meaning this number right here, if that's positive. If it's negative, then you're going to start going up and end going down. These are some things you might want to write on your note card. The things that I jot off to the side here, these are probably note card items. There's lots of little things in this section that you're going to want to have on a note card, so you're going to want to make sure you do your web work and your assignments that you have that this time. So the next thing says that if n is even, what's going to happen is they're going to change the same. So it's going to be up, up, down, down. So this is going to be same direction. Okay? Now for this one, if A is positive, they open up like a smiley face. If A is negative, they open down like a sad face. Okay? This one might be a little bit more intuitive, but this one is definitely going to be a little bit trickier to remember, the odd exponents. It's hard to keep track of those. So what we're going to do is look at a couple examples. So it says use the leading coefficient test to describe the right hand and left hand behavior of the graph. So the right hand and left hand behavior of the graph of each polynomial function. So first, this is even, which means they're the same, meaning they move up or down together. Since this is negative, that means it opens down like a sad face. So it starts down, starts pointing down, and it ends pointing down. Now it has 4 roots because this is a power of 4. So it's going to be something like this, okay? Because it's got to cross 4 times. We don't know exactly what it looks like. We're just kind of describing general behavior. So we've got 1, 2, 3, 4. But it should look something like this because there's 4 solutions and it starts and ends downward. The next one, we have an odd power, which means they're opposite. Our coefficient is positive. So if you look back, when the coefficient is positive on an odd, it's going to start up and end down. Oh, sorry, I misspoke, you guys. That's if it's negative. Sorry. We're looking at positive. We're at positive, so it's going to start down and end up. I apologize. Because this is positive, it's going to start down and it's going to end up. I apologize. So what that's going to look like if there's 3 solutions is it's going to look something like this. Starts on the downward point, ends on the upward, and it crosses 1, 2, 3 times because we have a power of 3. All right. So here, there's a couple things. It says zeros of polynomial functions. The function f has at most n real zeros. The graph of f has at most n minus 1 relative extrema. Basically, that just means whatever your power is, whatever your exponent is, that's how many zeros you have. That's not new information. We talked about that. But just keep in mind, you can have the same zero multiple times. So it's what we say, it can have multiplicity. Means it can happen more than once. We'll have an example of that here in a second. But one that you might see is like this. Never mind. We'll save it. We'll do this in the next one. So then there's a couple things here, like if x equals a is a 0 of the function of f, then what you might have is like, let's look at this example. I'll work this one out for all 3 of these things. So x squared minus 1 is like x minus 1, x plus 1. Here your zeros would be 1 and negative 1. It says x equals a is a solution of the function when you set it equal to 0. So again, x equals 1 or negative 1. X minus a is a factor of the function. So your factors are x plus 1 and x minus 1. These are called factors. These are solutions or zeros. Tomato, tomato, they really mean the same thing. Zeros and solutions, they're the same thing. Factors are these, where you break it into the parentheses. And then the x-intercept is where y equals 0. Well, y equals 0 when you get x equals 1 and negative 1. The whole point here is you set them equal to 0 to solve. So you set them equal to 0. That means our solutions in terms of an x-intercept are 1, 0 and negative 1, 0. Okay, those are your x-intercepts. So if they ask you for these various things about this polynomial, these are what you would write. Zeros look like this, solutions look like this, factors look like these, and x-intercepts look like coordinates like that. All right, so I'm going to try to get through one. The video might cut me off. If it does, I'll start up a new one. But it says find all the real zeros of the polynomial function. So we're looking for the zeros. We're looking for this. So first thing I would do is I notice there's an x in all of these. I would pull that out front, and we'd be left with x squared minus 2x minus 3. Then we can factor this a little bit more. We want to find 2 numbers that multiply to negative 3 and add to negative 2. Those numbers would be negative 3 and 1. So I would change this to x minus 3, x plus 1, like that. Then if we're looking for the zeros, we want to set this equal to 0. So set these 3 pieces equal to 0. X equal to 0, x minus 3 equal to 0, and x plus 1 equal to 0. If you solve each of these, x equals 0 is done. Add 3, x equals 3 here. Minus 1, x equals negative 1 there. Those are your zeros. All right, next one, same way. This one has 4 terms, 1, 2, 3, 4, and a power of 3. This is what I told you guys I'd use factor by grouping. So in the red parentheses, what I can pull out is an x squared.